Talking about energy assessment now, as I can see, we're all into the mood now, getting into the factories. So how do we start with an energy assessment? Why do I call it energy assessment but not energy audit? Because what I have seen generally that when we call it an audit, people take it as kind of a binding, especially the factory teams. They think, oh, an audit is coming in and they will come in and identify our faults. Because the objective of an assessment is not to identify problems. It's only change of a little bit words, but it just changes the context. For example, those factories who are working with brands, whenever they hear the word audit, they think that there is somebody coming from a brand, and now we have to ensure that none of our faults is identified and everything shows as 5-star. But when we go in the factories, in reality, there are many areas where they're lacking. And if they start hiding data, they start hiding situations, they stop their engine before you go in because engine is a pollutant. And then they say, look, we don't run engines because we are running on grid power. So you won't be able to assess it. So that is why I have stopped calling it energy audits. I always call them energy assessments, because assessment means that we together assess our current state and then we together try to improve it. But there are obviously different nomenclatures available and being used. So in this session, we're going to discuss how the energy assessments or audits are conducted, what are different requirements of 50,001 and 50,002, then methodology or scope of deep dive energy assessment, especially prominent programs like Partnership for Cleaner Textile or Clean by Design or different brand requirements. So a typical planning process is the manager says that I'll need a project plan to justify the resources we need to change our software. So he's telling the software engineer that we need some resources, but we need to have a plan so that we can get our management to allocate resources. The software developer says, okay, give me 10 seconds. He makes the changes without any resources and he says, done, it's been implemented already. The manager says, good work. Now all we need is a plan. So everything is done, but now we need a plan to justify everything that was done. So this is something that we need to avoid when we are doing the planning. Rather than spending too much time on planning, as we said earlier, go for the no cost, low cost measures right away when you identify them. So when I am in the factory conducting an energy audit and I see certain measures that can be taken without any investment, I do not wait for the energy audit report. I point it out right away and brainstorm with them the solution and then request them to implement it right away. What happens is that once they implement these kind of solutions during the audit process or assessment process, they build a confidence on the assessment process itself and on the assessors and auditors, which actually helps in motivating them and moving them towards the first right steps. So the energy planning process, as per IS 50001, is in a way that it's divided into 3 phases. Number 1 is providing inputs for the planning. Number 2 is the planning process itself, and then there are some planning outputs. So at the strategic level, it requires to identify the risks and opportunities of a company with regards to energy. For example, if there are risks of depletion of an energy source, if there are opportunities of moving towards renewable energy, for example, or if there is an energy source whose reliability is reducing. So talking about the strategic level, or if they think that there are any big brand requirements or customer requirements coming up that we need to address. For that, they need to understand what are the internal and external issues, what are the expectations of interested parties. We already discussed about this earlier. And then they need to make an action plan to address these strategic level issues. But then there is a tactical level as well, where we do an energy review. As Hung said earlier, that we do an energy review with the factory. And another colleague from our team also talked about energy review. So what it is, we based on The data, which data? Current energy types, past and present energy uses, the energy consumptions, greenhouse gas emissions, and the procurement records, for example, different type of data that we can get. We analyze this data and we identify what are the opportunities for energy performance improvement, what are the significant energy uses, what are the biggest and critical energy uses that consume a lot of energy and are responsible for the biggest energy cost. Then it is important to identify the relevant variables. So what is a variable? We say, for example, that last month we consumed 10 gigajoules of energy, but this month we have consumed 10.2. So how do we know that our energy performance has increased or decreased? For that, we need to know more about our process. So why did we reach from 10 to 10.2? Again, asking why is always the first question. Why does it happen? Are there contributing factors? For example, last month we had rainy season, so the moisture content was high in the air, and we needed more heat to dry the fabric. And this month is a dry season, and we might need less heat to dry the fabric. But because of dry season, now we need more cooling, which is increasing the energy consumption. So these aspects and variables we need to identify and understand what are the causes of the variation. Then determining the and prioritizing opportunities. So we see, for example, there are 20-25 opportunities that can be dealt with, but then we need to do prioritization. So which ones do we need to tackle earlier? Are these the big energy losses that we need to tackle earlier, or are these the no cost, low cost measures that we need to tackle, or are these measures which are more strategic in view because we need to show performance to our customer? So do we need to tackle those? So these are different aspects that we need to identify and which we need to use when we're prioritizing the opportunities for improving performance. As an output, we get an action plan of improvement, consumption trends, what kind of possible energy use we can have in future, significant energy uses, their energy performance indicators, energy baselines, objectives, targets, and also data collection plan. So this was only an energy review, and it is important to understand that regardless if a factory conducts an energy audit or not, this is a basic level of energy review that at least they need to have internally to have a process of assessing their current situation and trying to improve their current situation. Energy audit, on the other hand, in as laid out by ISO 50002, talks about a much detailed energy assessment. So level 1 is a walkthrough energy audit, where it talks which is suitable for small organizations, or if it's a big organization, we could use it as a preliminary assessment. And I'm sure you already do it before starting an audit. You go to the factory, do a walkthrough, take a note of what are the areas that you have identified, which are the focus areas we need to work on. Is management aware or not? Where do we need to improve their awareness? Is the team being provided proper training or not, at least basic training? Then collecting data of basic energy profile. What are the types of energy that we are using, and what are the equipments that we have, and what are their estimated loads, for example. In this, we don't need to do a measurement. Then conducting a very basic energy balance at the energy input level, that how much percent of energy we are getting from each of the energy types, and just qualitatively assessing what are the biggest energy users. At this time, we might not have enough data to actually quantify the energy users, but at least we might have a very high level of energy profile rather than having a very detailed one. And as everybody has been saying earlier, low hanging fruits, low cost measures, basic capital requirements, these are the opportunities that we identify here, and where we can start building trust in the company. Prioritization at this point could be only on the indicative savings because we don't not doing any measurements here. And we could tell, for example, if a company, replaces their lighting to energy efficient lighting, typically they save 20% or 30% with a typical payback period of 1 year or 1.5 year, for example. So this is all kind of a qualitative assessment rather than purely engineering assessment. But level 2 is called a detailed energy audit, which is suitable for single sites, not for multiple sites. But it is very detailed audit where the data collection is also very detailed for consumption side as well as energy procurement side. We need to understand which variables can be used to normalize the performance indicator. So if we have a performance indicator that says that 4.5 megajoules of energy is used per ton of product, for example, then we need to also identify what are the variables that affect this 4.5. Does it always stay 4.5 or does it vary? And if it varies, where does the variation come from? And then doing the monitoring using equipment, designing and operation and maintenance documents are required at that time. We need to understand what are the future plans of the company. We need to have production data as well. Then the analysis is conducted based on current and historical energy profiles, performance indicators, detailed energy and mass balance is conducted, and energy performance is evaluated in very detail. Designing configuration of the machinery, of the equipment, of the facilities is evaluated. And then opportunities can be low cost, medium term, and high cost measures as well. It is important to understand that energy saving measures also have non-energy gains or non-energy benefits. For example, if we improve parameters of a garment washing process in a way that it requires less energy, for example, we have a hot wash, and with a change in chemicals, we convert it into a cold wash. That would mean that we don't need any time or even less time now to heat up the water in the machine. So because we need less time to heat up the water, our batch time reduces by 5 minutes or 6 minutes or 10 minutes even sometimes. So if a batch takes 30 minutes, and if we have a cold wash, the batch time reduces to 20 minutes. So this 20 minutes is not only providing us energy benefits, but it is also providing us non-energy benefits like improved productivity, reduced time, reduced cooling requirements, because now we have less heat energy in the process. So overall space cooling is required less now. The performance of workers improves because there's less heat in the environment now, and they have a better working condition. So these kind of non-energy gains must also be indicated at this time. We also at this time might indicate what further data is needed, and we also start doing a benchmark comparison. Benchmarking could be external, could also be internal benchmarking. So if we have 4 or 5 machines of same quality, same type, producing same product, we could compare them with each other. Okay, machine 1 is consuming 4 kilowatt hours per kg of production, but machine 2 is consuming 4.2. And then we can do a detailed analysis, put up data loggers on both machines at the same time, plot their graphs on top of each other and see what is causing this difference. So that is how we can do some benchmarking. Prioritization, this needs to be done based on detailed savings that need to be reconciled with energy balance. So if we say that we have a saving of let's say $10,000, then we also have to see the energy balance. So the funny story, there was an energy auditor who went to a factory. I was working as project coordinator in a project at that time, not doing the audit myself. And when he was presenting the savings, he said that the factory will have X number of savings. And the CEO said, but our total consumption is less than the savings that you have identified. And everybody was amazed. Well, why? How can he identify savings more than the total consumption? And then we found out that the factory is working only 8 hours, and the auditor actually assumed that the factory is working 24 hours. So we multiplied the consumption with 3, and since the saving was about 40-45%, the whole total saving was more than the total consumption of the factory. So we need to always reconcile it with the balance and see, maybe sometimes we do a calculation error, and this calculation error leads to this kind of issues. And then also looking at basic capital and labor cost assessments, payback periods, implementation plan. This is how the prioritization is required by ISO 50002. What I add to this is to understand if there are any other factors which are more important than a payback for the factory. For example, if there is a legal requirement, if there is a compliance requirement, which is becoming very urgent, and the customer is really getting furious about it, causing penalties to the factory, these should also be considered in the prioritization process. When we come to level 3 comprehensive energy audit, it is suitable for a whole site or a set of sites or a group of companies. The red points that I have highlighted are the points which are different from level 2. So here we need to have sub-meter level data, sub-meter level load profile, not only at the main meters, but also at the sub-meters. Then we also need to have consumption of the processes themselves. As Hung also said, that we go to the machine level at level 3. Then detailed analysis of variables. So not only listing the variables, but also quantifying the variables. So if we say that our heating requirements vary because of the environmental temperature, then we need to have average at environmental temperatures, or the heating degree days, or the cooling degree days. So these kind of factors which can quantify the variables. So then we also need to have information on how the energy performance is managed, how the team is developed, what are they working for, what are the priorities they're working on, and then are there any quotations for energy saving opportunities from suppliers. Those are what we need to gather right at the data collection point, so that we know what are the issues that the factory is already working on. In opportunities, we need to not only identify the non-energy gains, but here we also need to quantify the non-energy gains. As I gave the example of the washing machine, the 10 minutes are saved. So here we also need to quantify how much water is saved because of this, how much time is saved, how much does this time saving translate into monetary value, for example. Then detailed analysis of advanced techniques, vendor evaluation. So if we have, for example, multiple quotes available, then we might also need to do a detailed vendor evaluation, not only technical, but also financial evaluation at that stage. In prioritization, detailed capital and labor calculations need to be done, detailed economic analysis, including IRR, ERR, and different kind of annuity comparison methods also need to be used here in the prioritization stage when we're talking about comprehensive energy audit. What I add to it is the life cycle assessment, which ISO 50002 has not mentioned in the description of levels, but it is mentioned in ISO 50001 as well. That life cycle assessment is very important. That here we not only compare them based on the feasibility on benefits and savings, but we also see that around the life cycle, how much savings will this present, and comparing different opportunities with each other. This we have already discussed previously as well, so I put it here only to build the context that what are the requirements by HIG FEM to conduct an energy assessment. We discussed that in level 1, it requires to assess and measure the energy uses and energy sources. In level 2, it requires to set up the targets, develop action plans, demonstrate savings. And level 3, which is not mandatory, it asks for setting long-term targets and going beyond our control talking about scope 3 emissions and setting science-based targets. So this is what GIFM is requiring, but pretty much derived already from ISO 50001 and 2. You can see that level 1 and level 2 are not very different from 50001, 50002 requirements, very much similar to those. Then talking about the deep dive assessments, many of you have already done that. I will try to summarize it here, that typically the deep dive energy assessments by brands and international organizations like IFC or other Clean by Design, Apparel Impact Institute, these are typically somewhere between level 2 and level 3 energy audits. They are not typically only level 2 or only level 3 audits, because they have their own priorities. And so the critical aspect here are quantification of energy saving potentials, especially in the processes, not only in the utilities, but also in the processes. Also talking about investment grade measures. So if you are, for example, working with IFC or World Bank, they are more interested in investment grade measures where the investment opportunities can be generated. Then talking about decarbonization strategy, which ISO 50002 is not talking about, how to replace fossil fuel, how to increase renewable energy in the fuel mix, for example, then improving management practices, which is common, and formulating energy team is also common among these. Feasibility studies are usually conducted only for selected investment grade measures. In case of these, not all the measures need to go through a detailed feasibility study. Then implementation monitoring usually varies from 2 to 6 months, and is usually part of the scope of the energy efficiency service provider, that they have to also monitor the implementation and provide training during the implementation phase. Vendor evaluation is also included in the monitoring phase generally, that the factories, if they are receiving any vendor quotes, they send their quotations to the experts for the detailed evaluation on financial as well as technical aspects. And then final impact assessment. Once the implementation monitoring phase is completed, the experts have to go back there, collect data for a day or two again, probably sometime, or sometime only rely on the factory data, validate the data, and calculate the actual impacts that the factory has achieved. So which measures were implemented, how much investments were done, how much emissions have reduced, and also which of the performance indicators are showing improvement and which are not showing improvement. So this is a typical deep dive assessment by brands and international organizations. When a company starts working on GIFM, uh, they have to start with level 1. And if they are able to answer the first 3 questions, that are the level 1 questions, properly with a yes or a partial yes, and if they provide proper data there, the level 2 opens for them. And then they have to put in data in level 2 and answer these questions. Generally, there are in different subsections: energy, environment, greenhouse gas, air emission, and all the other sections that they have. Some sections they are able to fill all the data in, so all the levels are open. In some sections, not all the levels are open. In case of energy, level 3 already opens along with level 2, because level 3 is not mandatory, but they can obviously take it step by step. But if they have not completed level 1, usually it is logically not really possible to complete level 2, because if they are not tracking their energy sources, and if they are not tracking their energy uses, they are not able to comply the first requirement of level 2, that is established baselines, okay, or establish energy intensive processes or operations. And if they are not able to do this, they're also not able to set targets for improvement. And if they don't have targets for improvement, how can they also have implementation plans? So they might still have some implementation plans, but those plans will not be systematic enough to fulfill the needs of this FEM. So typical audit tasks are defining audit and energy objectives. So why do we need to do an audit? As I said earlier, always ask, why do you need to do an audit? Why is the factory thinking about conducting an audit at all? Why are they not able to do it themselves? Why do they need an external consultant? Okay, so these objectives we need to identify first. Then determining scope. So I'm summarizing what we said. Determining scope, what is the criteria, how will we know that we have achieved what we wanted to achieve? Okay, and then defining the tasks. So what will be the tasks done during the audit? Where do we need to do the measurements? What is the responsibility of the auditor teams? What are the responsibility of the factories? Who will do the measurements? Who will provide the data? What kind of support is needed from the facility for conducting audits? And what kind of data do we need to measure and where? What kind of equipment is needed to conduct this assessment? Then formulating the audit team based on what tasks are needed and the scope and the audit objectives. Then we need to understand who are the experts that we need to include in our team, and who are the people in the factory that we need to include, and what tasks will be conducted by each of our team member. Then we secure top management support, break ice with key people. So we need to ensure that the key people, production guys, utility guys, they are not against us, but they are with us. So for that, we need to break ice. We could, for example, what I do usually is that I don't start with an audit, but I start with a 1 day training session where we have an informal training session. We have some fun activities there. We sit together, we talk about different aspects and we share our ideas with each other. That is where they understand that we are not there typically for a brand audit, but we're there typically for an energy assessment and helping them out. And remember the formula for change here. We need to move them away from the degree of satisfaction towards a degree of dissatisfaction. Then establishing communication protocol. So who will be the lead person among the auditors? Who will take lead in thermal area? Who will take lead in electrical area? Who will assess the management system? How will we interact with the facility? Who is the point of contact in the facility? How do we involve top management? How do we ensure that top management stays aware of the activities that we're doing and that we have full support from them? Then it is important to ensure that we have access to the audit areas, processes, facilities, that we are able to talk to relevant people. We are able to assess their monitoring system. We have access to their equipment, for example. So in a factory, they wanted to automate their knitting machines. And why did they want to automate? Because they had a lot of yarn breakage. So they first wanted to gather data of how much yarn breakage is taking place and when does it take place. So they had some PLC already installed there. So this PLC was made in China. The whole programming was in Chinese. So I requested them for the access to the code, but they were not able to provide me access because the vendor said that they cannot provide access to the code. So we could not move forward with that project. And we requested them to get it done with the main vendor who installed the PLC rather than, because if we would do it, we would have to install a separate PLC. So it is important for us to see what we can do and what we cannot do. If we want to do a stack analysis, ensure already that there are points available there for inserting the probe. If you want to do flow measurements, ensure that you are able to install your meter there. Then gathering the documents. So if a factory is hiding drawings, hiding test reports, hiding reports and records and manuals, it is very, very difficult to move forward with this factory. And this is the point we need to talk with top management very specifically, that we cannot move forward without this data. And calibration records and monitoring data is also required. Then defining what kind of measurements do we need to do more. So after having this data, we need to see, okay, what do we need to measure? What are the areas we need more detailed planning and measurement? So there are different stages to it. For example, we could do a point source measurement, for example, stack analysis or measuring the energy profile. Stage 2 could be a data logging. So rather than inserting the probe once and only measuring the point source emissions. We could install a data logger there, which could take profile of 2, 3, 4 days, and for the same time we could have the production data as well, and then we could make energy performance indicators. Stage 3 would be then to organize this data, analyze the data, identifying if the areas of improvement, and then doing the calculations and data visualizations in stage 4. So the factors that influence audit cost are the level of uncertainty and accuracy. Sometimes the data is not accurate, and also understanding to which extent the investment grade measures or longer payback opportunities are being identified in the factory, and if they are really interested in investment grade measures or not, what scope and boundaries they have set, if the data is available. For sometimes you go to factory and they don't have any data logs available other than the energy bills, and we have to manually make the data records. It actually affects on the energy audit cost as well, because then we need more person days to gather the data and compile the data as well. So there are different factors. So if the implementation monitoring support is required or not, how much distance do we have to travel, will factory be providing some resources to support us, or do they want us to do it all on our own? So all these things, these are variables which affect the cost of energy audit as well. Then there is a tool by Clean by Design. Clean by Design 10 best practice. I have filled this tool as an example for one factory. So the results of that tool can be actually used to do the scoring of the factory. For example, how much score do they get in measurement and management, if the condensate water collection and recycling is done or not, and then you can write comments. What are the issues that they have? For example, this factory condensate is not being recovered because there is contamination in the condensate, which is coming from leaking heat exchangers. So they are not recovering any condensate at all. So they get very low marks. They also get low marks because they are not recovering cooling water. And they get 0 marks because they don't have any hot water recovery system at all. They have very low marks in general in almost everything. So I will show you the tool quickly. We have different aspects under measurement of management. For example, first aspect is data management. If they have no data management, I would highlight this tool, this cell. If this factory had daily recordings of an analysis, so they scored 1, but they did not develop the indicators for energy and water consumption, so they could not score this, and a central monitoring system was also not installed, so they scored only 1 point here. In the next column, energy and process control, they complied with 2 points, that is water volume and temperature in the resin dyeing process is set and automatically controlled, so they got 2+ points. They had the equipment, initial water input is also controlled, so they had the water flow controller based on the moisture, so they got this point as well. But the humidity control system was not installed in all the machines, so I highlighted it yellow so that we can attend to it, so they get half mark here. So 2, 3 and 3.5, so they got 3.5 marks in this column. That is how I kept on scoring them. And in the last column, in the remark column, I then mentioned what are the areas that they're lacking in. And then the same comment was used in the PowerPoint presentation to show to the management the areas. But this tool was then available with the factory. And this tool was also evaluated by the factory themselves. So I only explained them the tool, and we did the facility round together. Then we evaluated each and every column and cell together, and the factory team decided what score they get out of it. And you can see that they were quite honest in this, because I knew the factory very well. At the end, if I scroll down, they scored only 53 points out of 150. And why were they honest? This is very important. There are factories who would try to score 150 marks directly without having doing something. and they would start fighting with us. Okay, no, we have to score this because they think that this score they have to achieve by hook or by crook. But this factory understood that we are driving change. We are not actually scoring them for the audit perspective. So this is a tool that can be used for training. This is a tool that can be used for baseline technical assessment. So the metrics that we saw in the previous session can be used for the management system assessment, whereas this tool can be used for the technical assessment. So the areas it identifies are measurement and management, condensate water collection and recycling, cooling water reuse efficiency, process water and wastewater reuse efficiency, discharge hot water heat recovery, boiler efficiency improvement, steam traps and steam system performance, insulation optimization, setting machine efficiency optimization, and compressed air system. One could argue that there are some aspects which are missing, but obviously we as experts should not stick ourselves to one tool. And as said earlier, that this is not 100% science. We can always make changes to the tools. We can always add aspects to the tools if we want, and we can use them in a way that fits to our needs and that fits to the client's needs. So this tool that they made was actually made to be used by the experts rather than the factory teams. But when I was using it, I found out that we cannot actually motivate the team if I do this assessment myself. And then they will not own this assessment as well. They will not drive the change. So I told them that this is their evaluation and they have to do their own evaluation. And I guided them based on the experience I had in their factory. And they brought to the right point, and then the energy audit that we did also was linking to many of these issues and some additional issues as well.